The first thing you want to do when you're object-oriented programming is think about what kinds of data you can package together to create objects. I mentioned earlier that this data right here has to do with the world, so we could make an object for the world here. This data here has to do with the player, so we could make a player object. But this data here is also related to itself directly, these two variables. And I can put them in the same object so that instead of dealing with two separate variables, I can instead start dealing with just one. I'm going to make a structure here called a coordinate. And the coordinate will have an x and a y variable, just like this here, and actually just like the player here. Now in place of secret location x, I can do this. Secret lock. And I can give secret lock x component the value 12, and I can give the y component the value 8. Now instead of using these two variables, I can use secret lock.x and secret lock.y. This actually will break my code. I can't compile it anymore because I just got rid of two variables that are very important. Down here, these two variables need to be replaced. So secret lock.x and secret lock.y. Let's compile that and see how it runs. That should still work. Oh, didn't even realize I got it the first try. There we go. So the x and y variables are member variables. Sorry, the x and y variables from here are member variables that belong to the coordinate structure. This structure right here is just created, but if I wanted to initialize it in the same way that I had initialized the other variables before them, I could do it like this. 12 and 8. And then I don't need these two lines anymore. This is called an initializer list, and this is something that you can do with a struct or a class that does not have something called a constructor. I can run this code and it'll compile and work. It will automatically determine that 12 goes to the first variable in the structure and 8 goes to the second variable in the structure. Somewhere around here. Where is it? There it is. Or I could make a constructor, and a constructor would look like this. Coordinate int a x, the a meaning argument, int a y, and x equals a x, y equals a y. Now because I have a constructor, I can no longer use an initializer list. An initializer list is something that C, the programming language that came before C++, used to use for its structures. This was before object-oriented programming was really structured in the way that it is today in C++. And when you start using object-oriented programming the way that it exists today, it basically rules out some of the old things that you could have done. But that's not too bad because C++ really gives you way more things that you can do. If you wanted to use the constructor to work the same way as the initializer list, you would just have to do that. And notice that when I have this parentheses here, I have these two options of constructors. A constructor is a function. This looks like a function except it doesn't have a return type. The return type is actually a coordinate. But this function accepts arguments, an x and a y, and this will work the same way. The x is set to 12, the y is set to 8. Whoa. Somewhere around here. There we go. Now because coordinate has a constructor, I'm not allowed to create it without one. For example, I couldn't do that thing I had before, the secret lock.x equals 12, secret lock.y equals 8, because secret lock doesn't know how to construct itself without any data. If I try to compile this, it'll tell me as much. It'll say it's missing a default constructor, no appropriate default constructor exists for class coordinate. I can make a default constructor that will automatically initialize the variables for me. That looks like this: coordinate x equals 0, y equals 0. And then I can run that, and look at that. The error went away, and now this works the same way that it used to. Bingo. There we go. So this is how you initialize data inside of the body of the constructor, but you can actually also initialize the data in a special part of the constructor called the Initializer List. And that's a little bit confusing because the thing that I did earlier here, 12.8, this I called an initializer list as well, but this here, x0, y0, is also called an initializer list. And when I do this, this little piece of code here actually gets executed before the function body of the constructor, immediately when the object is created. So this code really does happen in between the function being called and the body of the function being executed. I could put an initializer list for the parameterized constructor as well, like this. And this would work. The way that a initializer list works is this right here has to be a member variable of the class. For example, I couldn't do this. This is not allowed because even though this does belong to this function AX, this has to be a non-static data member of the class coordinate. And because this has to be a data member, even if I did something like this, there would be no confusion. This has to be the data member, and this has to be the argument that was passed in coordinate. If I didn't have that initializer list and I kept this argument name, I would have to write code that looked like this. Because x equals x, this is ambiguous. What does this mean? It means argument x equals argument x, or does it mean member x equals member x? Actually, what this means is argument x equals argument x. And that really has no meaning. So this line of code is essentially useless. It does nothing. But this code here is meaningful. This arrow, this meaningfully identifies this x as belonging to the data structure to coordinates x, and this x is the most recently scoped variable named x, which is the argument x. If I just do xx, I could do a y here as well, and all of this will work. I like doing this for simple data structures because it reduces the amount of code, and it is a little bit weird to read at first, but if you get used to it, you end up being able to write really, really short classes and structures that pack a lot of meaning. And that still works. Let me put the parameterized constructor in here. 12.8. So secret lock is now a coordinate struct. I want to change the player's location to be a coordinate struct as well. And I can do that like this. Coordinate lock 4, 5. Oh, how about 4, 5? There we go. Now because I took out the x and y variables, I have to replace all of the x and y variables with lock.x and lock.y. Lock, 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 and lock. Geez, that's a lot of lock dots. All of this object-oriented programming is kind of putting more syntax in the way of my programming. But there are some things that you can do with object-oriented programming that will actually reduce the amount of syntax that you need and make your code a little bit more readable. For example, this if statement right here, what is this really saying? This is saying if the player's location is the secret location. It'd be really cool if I could just do something like lock dot is the same as secret lock, or maybe even is. And this is actually something that I can do. This right here is a function that the lock object would be calling on the secret lock object. And it would look like this. Bool is coordinate, I'll just call the other one other, and return if x is equal to other.x and y is equal to other.y. And now this code will work. And this code I could probably get to work up here as well, because this code here is also a little bit tricky to read. So I could get this code here to look something like if lock dot is cursor, I'll call it, for row and column. Coordinate cursor, I'll just call it C. C dot y. Actually, C dot y starts out. I'll keep that there. C dot y is less than height. C dot y plus plus. C dot x. Well, C dot x is less than width. C dot x. And if lock is equal to C. Oh, the int I need to get rid of. And I need a curly brace. Then this will work as well. My player still draws, which means the is code is working in the draw code, and I still get caught by the if statement down here.